All right, pre-calc students, we are here, day 2, hyperbolas. Day 2! Exclamation point, because we're excited. All right, day 2 of hyperbolas. All of these, like right here, this box, this is big. This is big. This is stuff that you need to try to remember, or at least kind of comprehend to the point where you can kind of put things together when you're graphing these hyperbolas. All right. So first things first, what I'm actually going to do, I'm going to rewrite the form up at the top. And I'm going to say we have x minus h squared, and then we'd have r sub x squared. Then we'd have minus y minus k squared over r sub y squared, and that's equal to 1. I hope you remember, I don't feel like writing it right now, just because I want to get into it. But remember that ellipses can be like this, where x is positive, y is negative, or they can flip-flop. All right? So that's really important to remember. Because we know that we have to use or find the transverse axis by this first piece. Whatever the first term is, that dictates the transverse axis. Okay? But anyway, sorry. The slope of our asymptotes, all right? Slopes of asymptotes. We say are plus or minus, and then we use r sub y over r sub x. Think normal slope, right? It's y over x, change in y over change in x, rise over run. Same thing here. All right. Now, to actually get the equation of our asymptotes, we're going to use point slope form, where if we know the center is at hk, all right, if we know the center is at hk, then you're going to use y minus k, and I'll even put it in like this. Y minus k is equal to, and then you have to do both plus or minus slope x minus h. All right, that's just y minus y1 equals m times x minus x1, if you think that's easier to remember. All right, now, for focal radius, the equation is a little different. If you remember ellipses, you had to take r major, square it, and then take away r minor squared. Well, here we have a subtraction. That's your hint that we're going to add. But please remember, we don't talk about major and minor. We talk about transverse and conjugate axis. All right? So we have the transverse radius squared plus the conjugate radius squared. And again, what's really nice is you don't even really need to memorize which one is which, because you're adding them. It doesn't matter which one you take away. All right? So if you remember r squared plus r squared, you're going to be okay. Now we do need to know for the eccentricity the focal radius. We absolutely need that. And we always divide it by the transverse radius. All right? So that's all pretty important. I would hope that these couple of things are nice and easy. These are a little more difficult, but not too bad. And then really, this next part isn't too bad. If we remember again that the center is at hk, well then what we need to understand really is that the foci are just a distance away from that center point, either in the right-left direction or the up-down direction. And I hope you recognize there's actually a couple of options. All right, if x is transverse, then we know that the foci lie on the x-axis, or maybe not x-axis, but the horizontal piece. So we know that what we're going to have to do is we're going to have to take our center. The y value is not going to change, but we're going to have to add or subtract r sub f from the h value. Okay, what happens if y is the transverse? Well, then our x value is going to stay the same, right? So if y is transverse, it's very similar, but a slight difference, right? Again, now if y is the transverse axis, well now my h value or my x value is going to stay the same for my foci, but now we'll have to add or subtract the focal radius from k. All right, so right there is a big concept that we should probably kind of commit to memory. All right, our foci are either above, below the center, or to the left, right of the center. So now that we've done all that, let's get to work. We're going to do a couple of graphing problems and we'll call it a day. So really this is a good chance for you to catch up and really understand how to graph hyperbolas. Well, when we take a look at our general form, it's not quite in order for me. I like to write it as 4x squared minus 24x, then minus y squared plus 4y, and lastly, I want to move that constant over to the other side. Alright, and I do this because now I can complete the square twice. I see a 4 in front of x squared, so I factor it out. And that'll leave me with negative 6x. I know I'm going to have to put a blank, or leave a space in there, right? So I'm going to just put a blank in. Now, is the coefficient of y squared 1? No, it's negative 1. So I'm going to factor out a negative 1, which would leave me with y squared minus 4y, and then I'll have to put a blank in there. And that should be equal to negative 16, but of course we have to add the blanks. So now let's see. When we go and we complete this square, half of negative 6 is negative 3. Negative 3 squared is positive 9. That's not a 9 though, it's actually a 36. Alright. And then half of negative 4 is negative 2. Negative 2 squared is positive 4. Times negative 1 is a negative 4. And now we're getting somewhere. So let's go ahead and rewrite these, right? They're perfect square trinomials now. I can write this as x minus 3 squared. I can write this one as y minus 2 squared. And on the right side, well, negative 16 plus 36 is positive 20. 20 minus 4 is 16. All right. And hopefully you guys remember this. We see different coefficients, so we know that we have either an ellipse or a hyperbola. How do we know hyperbola? There's a negative. So we divide. We divide and we divide. Okay, so we know this will reduce. This will just become x minus 3 squared over 4, right? 4 and 1. This is just going to stay. So y minus 2 squared all over 16. And of course this is equal to 1. And so now we're good. Now we're good to go. All right. Hopefully you guys agree with me. Center, HK, 3, 2. R sub x doesn't really change. It's the square root of the x term, or the denominator of the x term. So we have a 2. Same thing with r sub y, square root 16, that's 4. Excuse me. Now, a couple of things real quick. We want to get the focal radius, alright? And so if we look at focal radius, usually we care about the transverse and the conjugate radii. Which one's going to be the transverse? Well, if my first piece is x, then this is going to be my transverse. Alright? So I'm going to go ahead and I'm going to say RF squared is equal to, well, 2 squared plus 4 squared. Or I can keep going, right? 4 plus 16 is 20. Or r sub f is equal to square root 20. We would probably want to simplify that to 2 root 5. Alright, 2 root 5. We do also, though, for the purpose of graphing the foci, we should have a good idea of what this is equal to. And hopefully you agree with me that square root 20 is between square root 16 and square root 25. These are 4 and 5. So I'm probably going to say that this is about 4.4, at least for graphing purposes. All right? But now we can go ahead and we can graph everything, guys. We have everything that we need to graph. So we know the center is at 3, 2. I plot it. I know that my x radius was 2, so 2 to the right, 2 to the left. I know that my y radius was 4, So 4 up, 4 down, and then I can kind of make that box, which is pretty important. Alright, something like that. Hopefully you guys can see. And what's great about that is because now we know where to draw in our asymptotes. And that is my next step. So I'm going to go ahead and put those in now. Asymptote, 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 asymptote. Then I'll draw in the other one. I'm really struggling at this. Sorry, guys. Something like that. Okay. And now we have to remember that because the transverse axis was x, we know this is going to go and open up in the x direction. So, at my vertices, I would do something like that. You want to get nice and close to your asymptotes. Alright, so there you have the hyperbola. Now, there are some more questions, right? It wants the eccentricity and whatnot, so let's get all of that. We know that the eccentricity is the focal radius over the transverse radius. So we had r sub f over r trans, and this was 2 root 5. Careful, transverse radius was 2. So the eccentricity was square root 5. And that is actually really good. If you remember from the other video, we said that in hyperbola, the eccentricity should always be greater than 1. So we're good. Now for the slope, it's just y over x. So plus or minus 4 over 2. Well, I would finish that up by saying plus or minus 2 for slope. My vertices, I would get right from my graph. Vertices, I would be 2 to the right and 2 to the left. So my vertices look to be at 5, 2 and 1, 2. And I just realized that I forgot to graph my foci, so I would lose points on this. Shoot. My bad, guys. Foci, the focal radius was about 4.4. So that means from the center, I need to go about 4.4 and 4.4. And maybe just put F for foci so that you know what those are. But now we can actually figure out where those foci were. Remember that these are both lying on the transverse axis, so the y value does not change, just like the vertices, right? I know that no matter what, my foci is going to have a y value of 2. But I do know that I'm going to start at the center and then add or subtract that focal radius of 2 root 5. And I would leave it just like that. Now, for the asymptotes, not hard, definitely algebra 1 work, but you just got to be careful. Alright, so we're going to do y minus, and our center was where? At 3, 2. And our m's were plus or minus 2. So I'm going to say y minus 2 is equal to, I'm going to do positive 2 times x minus 3. I'm going to solve. So when I distribute, I should get y equals, well, 2x. I had negative 6, but then I'm going to add 2, so minus 4. And that looks pretty good. That looks pretty good right there. So there's one. I do need to do one more. I need to do y minus 2 equals negative 2. X minus 3. So when I go ahead and I solve, well, I'm going to have negative 2x when I distribute. I'm going to have positive 6, and I'm going to have to add 2 again. So this is actually going to be plus 8. And what do we notice? 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's pretty good. All right, so there are our asymptotes. Please notice what I was doing. Did you notice how I checked? I strongly encourage you guys to check to make sure that you have your asymptote equations correct. All right? Okay, I'll try to get through this next one a little quicker. I know that I took a while on that first one just because I was talking about every little thing. So let's see. On this next one, it already looks like x is negative, so it looks like we're going to change transverse axes. Let's see here though. So we're going to go 4y squared plus 8y. We're going to have negative 9x squared minus 90x. and that's going to equal 257 for right now. Well, I'm going to factor out this 4, which leaves me with y squared plus 2y, and then I'm going to put in a blank. Then I'm going to factor out this negative 9, which should leave me with x plus 10x, x squared plus 10x plus a blank. And then, of course, that's equal to 257 plus blank plus blank. All right, let's figure out what's going where. Well, to complete this square, half of 2 is 1, 1 squared is 1. Remember, you got to multiply, so this is going to be a positive 4, excuse me. Let's see here, half of 10 is 5, 5 squared is 25. 25 times 9. Again, I know it's not easy, but if you think about this like as money, I think it makes it a little easier. Like, this is just 9 quarters. That's $2.25, or 225. Oh, what did I mess up? It's not a positive 9, it's a negative 9. So negative 225. Sorry about that, guys. And that definitely matters, because, let's see here. So now we have 4, we're going to have y plus 1 squared. We're going to have a negative 9, and then x plus 5 squared. And if we think about this, 261 minus 225, oh, that's not that bad. That's 36. All right. So again, different coefficients means we have an ellipse or a hyperbola. Negative tells us hyperbola. Divide by 36. Divide by 36. Divide by 36. These are going to cancel nicely. Or reduce, I should say. Reduce nicely. We have y plus 1 squared over 9. We have x plus 5 squared over 4. We have 1. Alright, not bad. Please be very careful. Remember, the y's and the x's switch spots. Center, you still look for your h and your k with the respective letter, right? So h is still with x, k is still with y. So our center here should be at negative 5, negative 1. R sub x is still with x, so this is going to be square root 4, or 2. R sub y is still with y, square root 9, or 3. What's the important thing for you guys to understand about this? Well, because y comes first, this, r sub y, is our transverse axis, which actually is down here, my bad. So we can just put that there, which means, of course, conjugate is going to be x. All right? Well, we do need to get r sub f, and to get r sub f, we do what? We say I'm going to come over here. R sub f squared is equal to r transverse squared, so 3 squared, plus r conjugate squared, or 2 squared. That's 9 plus 4, that's 13. So we know that r sub f is square root 13. And just to kind of help us out when we're graphing, we need to remember that 13 is between 9 and 16, right? It's actually closer to 16. But if it's between 9 and 16, then it has to be between 3 and 4. I'm going to say, just for graphing purposes, we're going to say about 3.6. But we now have everything we need to graph. All right? So let's do it. Negative 5, negative 1 is our center. Negative 5, negative 1. We know our r sub x and r sub y. So it's over 2's, it's up 3's, and we now have our rectangle, our box. And once we have the box, then we can sketch in the asymptotes. Alright, probably put some arrows so we know that they go on forever. Let's see, we knew the transverse axis was y, so we could actually graph everything, right? We know that it's going to open up and down. So something like that, and like that. Ooh, got a little close there. It'll be alright. And something like that, and like that. Alright, last thing that we forgot to do last time right away, foci. we know it's 3.6 above and below. So there's 3. So actually, these are really close. I'm going to even change colors again so I don't get too confused. Let's say we're going to put one right there and one right there. F and F. All right. Cool. So it's graphed. Now we just need that extra info. All right. Eccentricity, we remember, is R sub F over R trans. So we're going to say square root 13 over transverse was y, so 3. And that is our e value, eccentricity. Slope is nice and easy, plus or minus y over x. So 3/2. Vertices, we can look at the graph. It was 3 above the center. So what is that, -5, 2. And then -5, 3 below, or -4. All right. For our foci, because we don't have a great exact answer, they're kind of nasty, we're going to just write one big point. We know that the foci are going to lie on the transverse, so it's going to definitely have an x value of -5. What will change is the y value. The y value starts at -1, the center, but then you have to add or subtract that focal radius, r sub f, square root 13. Alright, now to finish this up, last thing, let's get the equations. So we know we have to use a center of -5, -1, m is plus or minus 3/2. Let's do this twice. So we have y plus 1 equals positive 3/2 x plus 5. When we distribute, we should have 3/2 x plus 15/2, and then I have to take 1 away. But remember, think about one common denominator, 2 over 2. So let's say 3/2 x plus 13/2. And we want to check that. 13/2 is 6.5. 1, 2, 3, 4, 5, 6. All right, not perfect, but that's just some error. I probably didn't I can see right here, I didn't line it up perfectly. So this is good. And let's hope that this next one's even closer. So we have y plus 1. Now we have our negative slope, but the same point. All right, same point, different slope. And we go ahead and we solve. So y plus 1 equals -3/2 x minus 15/2. Well, take away 1. Y equals -3/2 x minus 17/2. 17/2 is about 8.5, -8.5, and that looks way better, right? This one looks much more spot on. All right, so there we have it. There is some work on hyperbolas. Hopefully you guys are feeling better after a second day of watching me work on these. All right, we'll work on these in class. Have a good one.